So this section is very quick. It's just essentially getting used to the idea of common and natural logarithms. So log base 10, if you had to take log base 10 of some expression, a lot of times that 10 is just dropped and you might just see this. Okay, it's just, that would be sort of the common log. Unfortunately, some texts actually use this for the natural log, so I guess that could be confusing, but this one is very consistent, so we will stick with what we have in the text. So this is the log base 10. The log base e, we can denote that with ln, so that is the natural log. Okay, log natural. Okay, so for a lot of these problems, you're just going to use a calculator, and standard calculators usually have a button that is the log button, and that usually designates log base 10, and there's usually also an ln button which designates the log as with base e. Okay, so let's do the following simplifications. I encourage you to take out your calculator and see if you get the exact same results that I'm getting. So log of 426. So if you press the log button and then plug in 426, your calculator, we also want to round our answers to 4 decimal places where appropriate. So the answer is 2.6294 after rounding. Whoa. Don't know what just happened there. 94. Okay, and log of 0.4260, if you plug that in, this is going to give us negative 0.3706. Okay, now if you have log of x is equal to 4.8802, then this is the same thing as saying log base 10 of x is equal to 4.8802, and that translates to an exponential equation, right? So if I have the base, then this becomes the base to this power. So I have 10 to the 4.8802 is equal to x, and so we can use our calculator to simplify that, and we get x is equal to, so plugging this into your calculator, 75,892.6993, rounding to 4 decimal places. All right, if we have the natural log of x is equal to 4, that's the same thing as log base e of x is equal to 4, so that translates to the following exponential equation. E to the 4 is equal to x, and that's the exact answer, but we're trying to approximate. So if you plug this into your calculator, e to the 4th, there's usually an e button. That's exponential, and you would get 54.5982. So I know that I'm not actually showing you the calculator here, but I encourage you to practice using your calculator here. Okay, this is a very short section, so just make sure you're getting the same exact answers that I'm getting. If you're not, please let me know. Please email me, and maybe I can troubleshoot you through what your calculator's features might be, and that way you can use it. Next one, natural log of e to the y. Well, these two are inverse functions of each other. Natural log and the exponential e to something are inverses. So these essentially cancel and just give us the y back. Okay. Natural log of square root of e, well, I don't have e to a power until I write it, but this is e to the 1/2, and natural log and e are inverses, so they essentially annihilate, and I just get the 1/2 back. What about this right here? If I have natural log of 10 times e to the 4t, I can break that up as natural log of 10 plus natural log of e to the 4t. And of course, The 4 looks like a 9 because I wrote it really quickly. But we have natural log of e to the 4t. So natural log of 10, you can use your calculator to approximate this. And looks like this is 2.3026. Okay, and natural log of e to the 4t, natural log and e are inverses, so I'm just going to get that exponent of 4t. So this is our answer for this one.